Hi, today I'm going to present our work Visual Modality Prompt for adapting visual language object detectors that was accepted at ICCV2025. This work was done in collaboration with Feito Medeiros, Atif Belal, and Shirikant and Modality, advised by Professors Eric Grange and Marco Pedersoli at TTS. Object detection is the task of locating objects on image. We receive as an input the image, and we have as an output the class labels and the bounding box of the detected objects. A visual language model is a model composed of an image encoder and a text encoder, and used for different tasks like zero-shot prediction. What are visual language object detectors? These models are composed of text encoder, vision encoder, and fusion head, and they are used for open vocabulary, zero-shot object detection. In modality adaptation, we have different way to do adaptation of a detector while we use the detector feedback and we adapt this detector for different visual distribution. For example, adapting zero-shot RGB detector to work for an infrared image or a depth image. In visual language object detectors, we have two popular models. One is the YOLO word that is based on YOLO backbone, and the other one is the ground dyno that is based on dyno backbone. The YOLO word is pre-trained on a large-scale dataset and is really fast model. Ground dyno is affected using the fuse mechanism to fuse the language and the visual modalities. And it's really powerful model to do zero-shot detection. Modality adaptation, we have the Allustet and the ModTR that were proposed to do the adaptation of pre-trained RGB detectors for different distributions. The RGB detector on Allustet is from a closer distribution from the IR dataset, and in ModTR, it's the zero-shot COCO weights. We have different strategies to do the adaptation. After we have like a pre-trained object detector, we can adapt to a new modality by full fine-tuning, head fine-tuning. We can adapt by visual prompt that we adapt the input, or we can have our method modprompt. In modprompt, we translate the input at the pixel level for a better modality alignment, while we preserve the encoder knowledge via backbone agnostic design. It overcomes the failure of traditional pixel level prompts, and we have better cross-modality detection. We achieve superior performance, which is near fine-tuning performance across different modalities, while we retain zero-shot capability. So here is the proposed modprompt. We have the encoder, decoder, small model that we are gonna learn. So we learn this prompt, and then after we have the prompted image, we can use on the backbone of the detector. We also align this information of the visual prompt with the text prompt embeddings, and we do the adaptation of both parts using our proposed modality prompt loss. We use different datasets composed of different modalities like infrared, depth, event-based cameras, and LiDAR. And we can see that we have superior performance on infrared adaptation for YOLO word and ground dyno when we compare with different visual prompt strategies. And we have like a performance that's really close to full fine-tuning using much less parameters. We also beat the previous SOTA methods on modality adaptation, Allustet and ModTR, while we preserve the information of the detector. So our method can keep the whole information of the zero-shot model, and we adapt with less parameters. Here we did like ablations, comparing with the different visual prompt strategies. And we show that our method is quite good in terms of the trade-off between training time and inference time and detection performance. Here we can see some qualitative results showing our detection comparison with the mod prompt, visual prompt, and zero-shot model. In conclusion, our method is a novel method to adapt visual language object detectors across different modalities, conditioning on the visual prompt. We preserve the zero-shot capability with less than 5% of the parameters. We have superior performance compared with previous methods.